Let us try the 8-step plan for JavaScript. And probably, at this point, you all don't remember what the 8-step plan is. But back when we started looking at Ruby as a language, I said there's, as a seasoned software engineer, what you want to think about is not what language do you know, it's what is your game plan for picking up a new language. And I had proposed kind of this 8-step outline that you could use to approach a new language and sort of quickly get your brain into how to think in that language. So we're going to try that same template that I suggested for Ruby with JavaScript. By the way, everything that applies in terms of making your code beautiful and highly testable applies for JavaScript too. It's just, in some cases, a little bit harder to do. But all of the same guidelines and things that I've been hammering on in Ruby, functions should be short and have few arguments and do one thing and stick to one level of abstraction. That's fundamentally something that any good code should have. So keeping your JavaScript code separate from your markup, although depending on if you're using a client-side framework, that will go out the window. But for now, we're going to stick with that. I've been a stickler about trying to do test-driven, if not test-first development. And this idea of red-green refactor, where you actually try to write a test at the same time as you're writing the code, and then you're incrementally developing the code to make the test pass. We can do the same thing in JavaScript. And in fact, Jasmine, which is a JavaScript testing tool that we'll get an introduction to, was deliberately designed to look a whole lot like RSpec. So all of the same kinds of things that you can do, where you can set expectations, you can set up stunt doubles of objects, you can spy on method calls and return a canned value, all of those same facilities are available. They're just not quite as graceful to use. If you are going to spend a lot of time in JavaScript, you probably want to read Doug Crockford's book, JavaScript: The Good Parts, although some of what's in there is going to be, I think, obsoleted or rendered superfluous by ES6. And there's a whole bunch of different lint tools and sites and things like that that will help find common problems in your JavaScript. If you're already using CodeClimate, you're certainly using it for the project. But if you are doing JavaScript coding, I strongly suggest you continue to use it because they now have a pretty decent JavaScript linting engine too. So what is our 8-step plan? As a reminder, here's how the 8-step plan works. To approach a new language and start learning to think in it, we first ask, how does the language handle types and typing? Does it have strong typing like Java? Does it have dynamic or weak typing like Ruby? What are the primitives in the language? Are there primitive types of things? Are there primitive operations that are built in? How do you do bread and butter stuff like control flow, conditionals and loops? What are the basic types and things you can do on them, like strings? How do you talk about methods? Or depending on which language, some languages prefer to call them functions. That's what JavaScript calls them. Or procedures. So how do you define them and how do they work? Abstraction and encapsulation. How do you hide data? Is it like an object-oriented language with classes where the data inside of a class is more or less hidden to that class unless you make it public? Can you put groups of classes together? Can you sort of namespace things in a different way? So what are the mechanisms for doing that? Idioms. What are the things about writing code in that language that are going to look different from other languages that you may have used? And when we started Ruby, this was the one that I kind of referred to as you can write Fortran in any language. If you try to carry your coding habits from one language to another, very often you'll find yourself writing code that is not idiomatic, that experienced programmers in that target language would find awkward or difficult to read. So for example, in Ruby, you very rarely see, let's say, an explicit for loop iterating over the elements of an array. Instead, the Ruby idiom is you use each, and you provide a block that specifies what to do, and you let the collection manage its own traversal. So that's an example of a Ruby idiom. And as we'll see, there's a couple of idiom patterns that are all over the place in JavaScript, and that it's kind of hard to write serious JavaScript code without running into them. In future lectures, we'll talk about libraries and dependency management. The answer for JavaScript is a little bit different, in part because in the scenarios that we're mostly looking at, that JavaScript code is being delivered down to the client. And on the development side, you want to be able to have your code broken up across all different files and sort of structure it in a way that is easy to maintain. But on the client side, what you want is to deliver that code really fast and maybe compact, minified or uglified or obfuscated. So a lot of what we'll talk about with libraries and dependency management will figure in what's called the asset pipeline. How do you debug things? What does the IDE look like? If you go sort of beyond the JavaScript console window in the browser, what other tools are available for debugging, and how do you make use of them, and how do you write tests. And for that, like I said, we're going to introduce Jasmine, which is a lot like RSpec as a testing framework for JavaScript. So my hope is maybe we can get through like numbers 1 through 5 today, and we can start with 1 and 2, types and typing and primitives. So JavaScript Basics on the 8-step plan. And if you haven't tried it already, you can open a JavaScript console window in most browsers, and you can sort of try stuff out live. So how does JavaScript deal with types? JavaScript is interpreted, starting from that. Yes, there are JIT compilers, but fundamentally it's an interpreted language the same as Ruby is. It is dynamically typed, so variables don't have types, just like in Ruby. The objects to which those variables refer may have types, but the variables themselves do not. So like Ruby and unlike Java, you don't declare the type of a variable and then allow it to only ever name things of that type. The basic type in JavaScript is basically a hash. And in JavaScript, it's actually just called an object. The keys in the hash, if you're talking to a JavaScripty person, they may call those keys slots or properties. Those are actually names that descend from self and from Smalltalk. So here's a simple example of an object. I've assigned the variable movie, and we'll talk about the var keyword in a moment, to an object that has 2 slots, a title slot and a release info slot. The title slot has a string value. The release info slot has a value that is another object. So objects can nest. Notice that in my nested object, I chose to leave out the quotes around the slot name or the property name. They are optional if the slot name would otherwise be a legal variable name. So rating would be a legal variable name, but you can give slots names that happen not to look like a variable name. If you've been playing around with APIs, even beyond our very basic initial API assignment, if you're looking at JSON objects, right, and now it's quite clear where it comes from, right? JavaScript object notation is really just a way of deserializing or serializing one of these JavaScript objects. In JSON, it is always required that the slot names have quotes around them. So depending on the code you're reading, right? If you're looking at an object that came from a JSON API, you'll probably see quotes around every slot name. If you're looking at JavaScript code that defines objects with a bunch of slots, you'll often see the quotes being left out. So it's either way. It's like the 2 different ways of doing symbols in Ruby. You just have to get used to it. JavaScript is single-threaded. This is a source of much confusion among people who are approaching the language. There is no concurrency abstraction at all in JavaScript. There are no locks. There are no semaphores. There are not multiple threads. There is no parallelism of any kind. There are libraries, things like web workers, that make it possible to run multiple separate JavaScript threads, but each interpreter basically is running in its own thread. And this is a decision that goes all the way back to the fundamental design of the language. And hopefully, as we talk about the differences between the JavaScript programming model and others, you'll understand why that design decision was made and how it's a great fit for certain types of programming problems and a sort of awkward and uncomfortable fit for others. So that's the basics of JavaScript types is basically that. There are a few primitive types, like a number is a type. There are strings, there are arrays, and the basic object is essentially a hash. Browsers and scope. The JavaScript runtime is expected to have access to one special object that's called the global object, which defines a handful of things about how JavaScript is connected to the environment in which it's running. So when JavaScript is running as part of a browser, the browser defines a global object, among which, for example, one of the properties of the browser's global object is a JavaScript object that refers to the current browser window. If JavaScript were running, let's say, as part of a desktop app, in other words, if it were running not in a browser environment, or maybe it's running as a server on something written using Node or Express, the global object would have some quite different stuff in it. And the idea of the global window, let's say, wouldn't exist, because those are entities that are defined by a global object that in some sense ties the JavaScript interpreter to a particular kind of environment. This is one of the standard keywords in JavaScript, kind of like self is in Ruby. So if you use this in global scope, it's whatever the global object is. So if you were one of the people who, when I asked how much JavaScript have you seen, if you've looked at sort of other people's JavaScript and you see things like this.document.window or this.window, that's what's going on there. In the context of a browser, this names the global object if it has no other qualifiers, And the browser defines a global object with slots like window and document to describe what the current window and document are. If you see this inside the scope of a function, then it refers to the object receiving the call, just the same way as self would in Ruby. Okay, so get used to seeing this. Each page in a browser gets its own global object. Again, another source of much confusion. So, and when I say a page, it's not just the window, right? If the window is now reloaded from the server as the result of a new HTTP request that brings in a new top-level HTML document, then a new copy of the global object is created for that. So every web page is really pretty much isolated from every other page because the global objects are not shared between them. There's effectively no way for those pages to use JavaScript to communicate with each other. Now, again, there are tricks you can do. You can have a page that creates a pop-up or a child window, creates another child window, and thereby has references to both of them, and you can pass information between them. So there are ways to get that done. But in terms of the fundamental programming model, every window has its own global object, and for all practical purposes is independent of every other window. One consequence of that is, from the point of view of your server-based application that is serving HTML pages, every single HTML page has to separately load whatever JavaScript your app relies on. Now, that's not really as bad as it sounds. First of all, browsers are pretty smart about caching. And if you load a JavaScript file and then a few seconds later you have another page loaded that asks for the same JavaScript file, as long as the browser can determine that the underlying file hasn't changed at the server, it'll just use the local copy. So it is not the case that every single JavaScript page request will actually cause a new load. And as we'll see, things like the asset pipeline will go further than that, and they'll actually take all of the JavaScript pages of your app, mash them into one big blob, do a bunch of interesting compression, and cause the one big blob to be sent down instead. And for the most part, you get to be oblivious to that. So in terms of implementation, it is not usually the case that you're going to do a lot of separate JavaScript page reloads. But in terms of the programming model, that's what's happening. Every single browser page that gets loaded has its own copy of the universe, and any JavaScript code in your app has to be explicitly loaded into that copy of the universe. And when we talk about the asset pipeline, we'll show that Rails and other frameworks often have a higher level way for you to say as part of your page, load JavaScript required here. So that in development mode, it'll actually load all your little tiny JavaScript files that you can be modifying as you're debugging. But in production mode, it will cause all those files to be grouped up into one big blob, and then the blob gets served. Maybe you even serve that blob from a content distribution network or something else. Okay, so we'll talk about that when we talk about the asset pipeline. That's why it is not a problem at all to divide your JavaScript code across separate files. Just like in Ruby, you would sort of put each class in its own file. In JavaScript, each collection of related methods on an object, or if you want to call them a class with ES6, can go in their own file. You organize them to make them easy to maintain. So you find things in places that are sensible, not having to worry about the fact of how they're going to actually be provided efficiently down to the browser in load time.